Okay, why don't we try solving a problem that involves an arithmetic sequence? Because that is fun to do. I think you guys might like this. Maybe. You'll have to let me know, and I'm sure you will. Okay, a high school auditorium has 18 seats in the first row and 26 seats in the fifth row. The number of seats in each row forms an arithmetic sequence. What that means is that you're adding on, because you went from 18 to 26 seats, you're adding on the same number of seats every row. What is the explicit definition for the sequence? So remember, our rule for explicit definitions is a sub n equals a1 plus common difference times n minus 1. So what information do we have? We know the first term has 18 seats in the first row. So we know that a1 equals 18. And then the other thing we know is that there are 26 seats in the fifth row. So take a look. The first row, A1, equals 18. So I'm going to say that the fifth row, A sub 5, when I say sub, that's just a subscript to tell you to write it kind of smaller in the subscript position. Sometimes I might just say A5 or A sub 5. Same thing. All right, so A sub 5 is equal to, we have 26 seats in that row. In order to write the explicit definition, we need the first term, which we have, and we need the common difference, which we don't have. But we can use this fifth term to help us find that. Let me show you how that works. So I'm going to plug in what we know. We know the first term is 18 plus that we don't know the difference. And then we have some stuff we do know. We know that the fifth term is equal to 26. So the fifth term, that's your n. N equals 5. That's this n right here, your fifth term. So I'm going to go ahead and put 5 right there, minus 1. And then what we're forming is the fifth term. Well, a sub n is the fifth term, and we know the fifth term is 26. So we have a 26 out front. So this a sub 5 equals 26. The subscript is your n, going in right here for n, and that will give you the 26th term. And this whole thing, if we put a 5 in for n, this whole formula will give us the fifth term, which is 26. Now we just solve. So to solve this, we'll start by distributing our common difference. I'm going to start writing over here. We have 26 equals 18 plus 5 times d. Oh no, we're not distributing. Silly me. You can just do parentheses first, right? Let me undo all that. Even easier. What is 5 minus 1? I'm still going to write it over here though. 26 equals 18 plus 5 minus 1 is 4. So d times 4 or 4d. And then we just solve for d. We'll subtract 18 from both sides. So we get 8 equals 4d. Divide both sides by 4. And our common difference is 2. The question was, what is the explicit definition for the sequence? You need the first term, which we have, and you need the common difference, which we now know. So we can write this formula. It's going to be a sub n equals the first term 18 plus the common difference 2 times n minus 1. That's our explicit definition. Okay, we have a follow-up question. How many seats are in the 12th row? So we can use our rule that we just wrote to find however many seats really in any row that we want to. So let's see. I'm going to write that over here. A sub n equals, there we go, 18 plus 2 times n minus 1. Okay, if you want the 12th row, that's the 12th term. That's an n value. So a sub n equals, we're just going to plug in a 12 for the n. 12 minus 1. And then we just keep simplifying. 18 plus 2 times 12 minus 1 is 11. 18 plus 2 times 11 is 22. And then 18 plus 22 is 40. So how many seats are in the 12th row? 40 seats. And that's our lesson. This one felt very fast. I like it.